Hi, good evening to all. Now I am going to discuss about question number 1. Here in this case, a balloon is moving vertically upward with constant acceleration g by 2 in upward direction. Particle A was dropped from the balloon and 2 seconds later another particle B was dropped from the same balloon. Find the separation distance between A and B 6 seconds after dropping the particle B. Here in this question, G values is given G equal to 10 meter by second square. So here we have to find out the separation distance between A and B after 6 seconds later the particle B is dropped from the same balloon. So here this is the ground. From the ground at a certain distance h1, at a certain distance h1, now the balloon is at here. So at t equal to 0 second, the particle A was dropped from the balloon. After a certain height h2, after 2 seconds, t equal to 2 seconds, from the same balloon, particle B was dropped. Initially, the acceleration of the balloon A equal to g by 2. The acceleration of the balloon is upward. Here the acceleration of the balloon is A equal to g by 2 upward. When the particle is dropped from the balloon, the particle moves downward, that is g. The particles of acceleration of the particle is downward, that is A equal to g. The acceleration of the particle A equal to g. The acceleration of the balloon is A equal to g by 2. The acceleration of the particle A equal to g downwards. The acceleration of the balloon A equal to g by 2 upwards. So here the time of flight of the particle A and B. The time of flight of the particle A equal to 8 seconds. The time of flight for the particle B equal to 6 seconds. Why? Because particle B is dropped after 2 seconds later. Here we have to find out the separation between A and B after 6 seconds later dropping the particle from the same balloon. So the time of flight of the particle A equal to 8 seconds, the time of flight of the particle for B equal to 6 seconds. Here in this case, we have to find out the separation between separation distance between A and B. So, by using equation of motion, the displacement of particle A after dropping. So S equal to ut plus 1 by 2 at square. This is equation of motion. Here initially the balloon moves with velocity u naught. Then at t equal to 0 second, when the particle is dropped, then its velocity u1. Then after 2 seconds, the velocity of the balloon is u2. Here the displacement of the particle A after dropping S A equal to the velocity u1, the time S, that is time of flight of the particle 8, then minus 1 by 2 for A G. instead of g, that is a g, then t square 8 square, right? So S A equal to 8 u1 minus 1 by 2 into 10 into 64. S A equal to 8 u1, 1 2s are 2, 5 2s are 10, that is minus 64 into 5, 320. This is the displacement of the particle A. Then displacement of the total displacement of the particle. The total displacement of A. So the total displacement of A is represented by A, S A dash. This is equal to H1. H1, that means after a certain distance the particle A was dropped from the balloon. So S dash A equal to H1 plus S A. That means S A dash is equal to H1. We know that the values of S A plus 8 U1 minus 320. Right. Now we know that values of the SA1. That means total displacement of the particle A after dropping. Likewise, we have to find out the total displacement of the particle B after dropping. Yes, the total displacement, or that first the displacement of particle B after dropping. After dropping, that means again using the equation of motion, SB equal to, here after 2 seconds the particle B is dropped from the same balloon. So the velocity equal to, initial velocity equal to u2, right? Then the time equal to 6 seconds. Then minus 1 by 2, here g is equal to 10, then t square equal to 6 square. So this is S B equal to 6 u2 minus 1 2s are 2, 5 2s are 10, 36 into 5, 180. So this is the displacement of the particle B after dropping. Then again we have to find out the total displacement of the particle for B. The total displacement of the particle B. So the total displacement includes both H1, H2 and SB. So the total displacement of the particle SB dash equal to H1 plus H2 plus SB. Yes, here SB dash equal to H1. Yes, here H2, what about H2 plus H2 plus SB? We know that 6 U2 minus 180. Here we have to find out the H2. That means the height, the displacement, that is height H2. Here in this case, the H2 equal to, yes, the initial velocity U1, right? Here for H2 equal to U2 into T, here U2 into T, T equal to 2, right? Then here minus 1 by 2, here the acceleration of the balloon A equal to G by 2. Here before that we consider the acceleration of the particle in case of the displacement equation. To find the values of H2, again we use the displacement equation U2 instead of T2 minus 1 by 2 G by 2. Yes, the acceleration of the balloon is G by 2 into T square, that is 2 square, right? So this is H2 equal to 2 U2, then minus 1 by 2 G2 into 4. 1 2s are 2, 2 2s are 4, 1 2s are 2. So this is H2 equal to 2u2 minus g equal to 10. Here it is given g equal to 10. This is the values of the H2. Then we can substitute the values of H2 also. Right. So the Sp dash is equal to H1 plus H2 2u2 minus 10 plus 6u2 minus 180. Again here we can add this H1 plus 8u2 minus it here minus 180, then 190. This is Sb dash equal to minus 190. Again we have to find out the values of u2. Here u2 is nothing but it is the final velocity. By using the equation v equal to u plus at, the final velocity u2 equal to, for u that is initial velocity u1 then plus a is equal to acceleration g by 2, then time t equal to 2 seconds, then 2 cancel, then u2 equal to u1 plus 10. So v equal to u plus at, that is final velocity, initial velocity, acceleration of the balloon, g by 2 into t. So by substituting values of u2 in this equation, yes, b dash equal to h1 plus 8 instead of u2 u1 equal to u1 plus 10 minus 190. So yes, b dash equal to h1, this is plus 8u1 plus 80 minus 9. Then we can get, so Sp dash equal to h1 8u1 plus 80 minus 190. Then we can subtract these values h1 plus 8u1 by subtracting this minus 110. Right. So this is the values of, that is the total displacement of the particle B after dropping. Here already we know that the total displacement of the particle A after dropping. This is equation 1, this is equation 2. By subtracting these two equations, Sb dash minus Sa dash, this is equal to Sa dash equal to h1 plus 8u1 minus 320, then minus h1 minus 8u1, then plus 110. So by subtracting this, here h1 8u1 minus 330, here h1 Sp dash is minus 110, Sp dash equal to 81 minus 110, here h1 minus 81, this is minus into minus plus 320. So h1 cancel, 8u1 cancel, then the total separation between B and A, Sp dash minus Sa dash equal to 210 meter. Yes. So after 6 seconds, particle B is dropping from the same balloon. The separation between A and B is 210 meter. Right? Thank you.